This is the Caper final demo from Group 12. The idea behind Caper is that we are taking an older technology in animatronics and intermingling it with a newer technology in AI. AI can be seen as scary, especially considering how fast it's developing, so taking this opportunity to showcase it as a fun project that can talk to you, talk back in the shape of a friendly bird, is a different perspective on how you can do things. So the objectives behind Caper is that it has realistic smooth motion, and we use solenoids to make this happen. Caper comes with speech detection, so it can understand when you're talking to it. It also has multiple input modes, up to 4, so that you can interact with it in many different ways. And then as well, Caper can talk to you on its own with a realistic and intelligible response and keep a conversation going. Our chassis was 3D printed and is going to house all of our important components, those being the Jetson Nano, the relays, the IOCB, the power supply, and our board, as well as the buttons you can see down here in the colored buttons. During this project, we had 3 iterations of different PCBs, all with varying functionalities, but our last PCB, Volume 3, worked. Here is the 3 different images that show the 3 stages of the PCB. In the bottom right was our design in Altium with all of our connections. In the top right is the 3D model that we sent off to JLC PCB to be created. We actually only had them create the boards, and we ordered all of the components ourselves so we could solder them on by our own hand. And that is what you see here in the last picture, our final board with all of the connections and buttons implemented. Here is the body of Caper. On the left is the parrot with no inputs being pressed, and on the right is all 4 buttons being pressed, so all 4 movements are active. Taking a look at our specifications and what our goals were for this project, the important specifications were that the bird responded to its name at a high clip, as well as the response that the bird gave when you talked to it was accurate to what the conversation entailed. We also wanted it to respond in a meaningful amount of time, similar to that of like an Amazon Alexa. And then as well, for the hardware part, we wanted the button input to be essentially very fast. We put 2 seconds as our time, but after doing some testing, it never even came close to that.
Here's a basic overview of all the hardware for Caper. Starting with the main body, you have the mouth and head solenoid at the top. At the midsection, you have the body solenoid, and on the rear of the mid, you have the tail solenoid. This silver box is the high voltage power supply that powers the solenoids, the external relay board, and this is the IOCB or input output control board. Now it's time to demonstrate the buttons. Pressing the yellow button will activate the mouth solenoid. Now pressing the red button will tilt the head forward. Pressing the blue button will tilt the body forward. And pressing the green button will tilt the tail up. Now let's demonstrate the selector switch. Turning the switch on will automate the head, body, and tail in an arrhythmic fashion to create the illusion of freedom of movement, as if the bird were actually alive. In this case, the 3 corresponding buttons for those movements are disabled, but the mouth is left completely manual. This allows the user to control the mouth freely using either the yellow button or the Vox circuit. Right, now I'm going to demonstrate the Vox circuit. So, here's my microphone. I'm going to now speak into the microphone. As you can see, the switch is deselected and all of the buttons are unpressed. Hello, testing 1, 2, 3. Hi there. Hope you're having a nice day. So what I can now do is flip the selector switch to automate the head, body, and tail. And as you saw before, the mouth stays manual. So I can now take the microphone again and talk. Make it look like he's fully alive. Hello. Ha ha ha. My name is Caper. And now I am actually working on the custom PCB. Yoo! Now it's time to demonstrate the MIDI capability. Using my digital piano, I'm going to press the middle 4 keys to trigger the 4 movements. Pressing C4 activates the mouth, as you can see. Pressing D4 will tilt the head forward, just like the push buttons. Pressing E and F4 will trigger the body and the tail respectively. As you can see, there's the tail moving. And there's the body. You can press any of the movements in any order. Here's a close-up of the relay board lighting up as each of the 4 movements are pressed. Here we are now testing the engineering specification on push-button response time. We specified a 2-second limit for each of the 4 movements to return to their resting state whenever a button is pressed. Now, electrically, the response is almost instantaneous, but there is some slight mechanical delay, but we've minimized that as we improved the main body. Now, of the 10 trials we took, we're only showing 3 of them here, so 3 long and 3 short pulses of each of the 4 movements. The mouth, head, and body worked great. Now there's the tail short pulses, now the tail long pulses, working great, all well under 2 seconds.
So here is that test run with the hardware. We initially had some issues with it not working at a 100% rate, but that was just because the relay board had 2 faulty channels. So we subbed that out, and now it works flawlessly and responds to every input. As you can see, we easily met our time goal, and though there is a little variation, it never even gets close to 2 seconds.
And that's running through, and so it's running independently, and you're running through the wireless.
Final software stack. For communication, our system uses OpenSSH between the edge and server. For our ASR library, we use Whisper.cpp. For a Llama library, or for our LLM library, we use Llama.cpp. Our large language model is Llama 7B Instruct, and Whisper base for our large language model weights and biases, and ASR weights and biases, respectively. The programming language we use for the edge is Python 3.10, and the programming language we use for the server section is C++. We're using Google Text-to-Speech as our text-to-speech library. So, over here I have the server running on a separate desktop. As you can see, it is a SSH connection. Over here I have the Nano connected to the Parrot via a MIDI cable, which is right here. And right now the MIDI is being, or the Jetson Nano is being controlled via an SSH connection through this USB cable. However, this system can and will run independently once I start the appropriate service, and that will be started during the actual runs. So this is just showing that this is connected to our IOCB, and this will be running our relay board.
System, how's your day going?
Okay, everything's connected.
Alright, send it to C. Oh, C. So that's the closest.
Just to get it to room.
A sunny day with a few clouds here and there.
System, who are you and what do you do?
I am an AI parrot, and I love to chat.
System, what's 7 multiplied by 42?
That would be 294.
System, how is your day going, system?
That would be 294.
I get the point of the bus.
Caper or system or whatever. What is, or yeah, how is your day going?
But right now I feel like we have extra voltage because we taped it to the poster board and then we cut where we taped it.
My day is going great. I am so excited to learn new things and meet new people like you.
System, Caper, that is good to hear. What is your name and function?
Goodbye, user.
System, what are you talking about? I never said goodbye. I asked you what your name and function was.
Oh, my bad. Sorry. My name is Caper, and I am an AI parrot prototype built by UCF engineering students in their capstone project.
Caper, what is the multiple of 42 and 7.
Oh, no, those are rock solid.
Oh. Caper. What is the multiple of 42 and 6 plus 1?
Oh, that's perfect.
The answer is 279.
I'm gonna hit enter. Yep.
15 whole dollars.
Hello there, Caper. How are you feeling today?
Okay. Well, hopefully that works. Yeah, you want to set it off?
I feel like I could use some more training data and model improvements.
It's right there. So.
Caper, what is the purpose of your creation as an animatronic parrot system?
What? No way. Can you stop it? What?
The purpose of my creation is to provide entertainment and education through interactive conversations with humans.
Caper, what is the answer of 42 multiplied by 7?
Yeah, no, it's not gonna burn up. The heatsink doesn't get any hotter than like probably. It's also
Try again.
Caper, what is the answer of 42 multiplied by 7?
crazy is what it is. It's funny, you can feel it move.
I want to have system in there as well.
System, what is the answer of 42 multiplied by 7?
That would be 294.
Across all runs, we have an accuracy of an average of 96.875%, with a response speed in the lower end of 6.7 seconds and on the high end 12.6 seconds. This represents double what we wanted. However, the main reason is the new software required has a much larger time to recognize when speech has stopped. This cannot be mitigated given the fact that the tests were conducted in a noisy environment. That also could not be helped. The name response rate is relatively decent at 69% overall across all tests. This is well within spec and is reasonable given our constraints and noise. As a result of all these tests, we have determined that the system does its job well. We have good relevancy, and it's rather robust to noise once the naming problem is circumvented. One of the main issues that we've still found is that the context window is small, meaning that larger conversations are a problem. However, we do have some internal systems that reset the conversation state once we get to a point where it breaks. This results in a conversation that resets over time, but for long sustained conversations that is not possible.
Now, some applications for Caper. It could be used in a variety of different places as well. The main idea behind Caper is that it's not just specific to a parrot body. It could be used for any sort of animatronic. The only difference would be the frame, but it's still all the same technology. So because of this, it could be used in many different theme parks, especially with Super Nintendo World coming down to Orlando, and their live use at animatronics, if they had one that responded, could be a great attraction. As well, it could be used in live children's entertainment or just as a mascot for any certain company. So Caper is very variable and very applicable to a lot of different situations.